In this video, we are going to analyze maximum kinetic energy versus frequency graph. So let's start with the equation for the maximum kinetic energy. Maximum kinetic energy equals HF minus HF0, right? So this is in the form of Y equals mx plus c, where Y is maximum kinetic energy, m is h, x is frequency, c is minus hf0. Yeah, that means if you draw a graph with maximum kinetic energy on the y-axis and frequency on the x-axis, you must get a straight line. So y is equal to mx plus c is the equation for straight line. You must get a straight line, and the slope of this straight line must be the Planck's constant. You know the equation for slope, right? y2 minus y1 over x2 minus x1. So let's analyze maximum kinetic energy frequency graph. So we have maximum kinetic energy plotted on the y-axis, frequency plotted on the x-axis. We have 4 different metals: sodium, magnesium, cesium, and silver. Okay, let's consider cesium. Cesium. So let's find the slope of this graph. We need 2 points. These are the 2 points. Let's call it A and B. So this point is on the x-axis 6 times 10 to the power of 14. It's 6, but you need to multiply with 10 to the power of 14. 6 times 10 to the power of 14, comma. On the y-axis it is 0.534. It's directly given, 0.534 electron volt. Not writing the units here. Okay, and point B is 10 times 10 to the power of 14. That's the x coordinate. 10 times 10 to the power of 14, comma, 2.19 electron volt. That's the y coordinate. Now let's find the slope of this graph. How do we find the slope? M is equal to y2 minus y1 over x2 minus x1. So this, let's say this is x1, y1, and this is x2, y2. Put the values in. M is equal to y2 is 2.19 minus y1 is 0.534 over x2 is 10 times 10 to the power of 14 minus 6 times 10 to the power of 14. If you do that, you will get 4.14 times 10 to the power of minus 15 electron volt per hertz. I'm converting electron volt into joules, so multiplying with 1.6 times 10 to the power of minus 19. So 4.14 times 10 to the power of minus 15 times 1.6 times 10 to the power of minus 19. Just converting from electron volt to joules. So you'll get 6.624 times 10 to the power of minus 34 joules per hertz. And this constant is called the Planck's constant, H. Keep this in mind. To convert from joules to electron volt, you should divide with 1.6 times 10 to the power of minus 19. And to convert from electron volt to joules, multiply with 1.6 times 10 to the power of minus 19. Okay, so that's how we find the Planck's constant from maximum kinetic energy frequency graph. Just find the slope of the graph. Now there is one more thing. So the x-intercept for cesium, this is the x-intercept, right? The point where the graph intersects the x-axis. This is the x-intercept. And that is the threshold frequency f0. That is f0, threshold frequency of cesium. And now for sodium, this is the threshold frequency. It's around 5.8 times 10 to the power of 14 hertz. For magnesium, it's around 8.8 times 10 to the power of 14 hertz. For silver, it's around 11.2 times 10 to the power of 14 hertz. To find the threshold frequency, just find the x-intercept, the point where the line intersects the x-axis. That is your threshold frequency. In short, if you have a graph, I'll draw a graph. So this is maximum kinetic energy frequency graph. Slope of this graph is Planck's constant h, and x-intercept is the threshold frequency f0. So this point here is the threshold frequency f0. You can see below threshold frequency there is no photoelectric emission, right? Yeah, that's why it's a flat line here.